billions of light-years away from Earth, something unexpected has been discovered in the darkness between galaxies. Is not a star, not a planet, not even a nebula, but an enormous ring of radio energy unlike anything astronomers expected to exist. Is so large that it could swallow entire galaxy clusters inside it. When a radio astronomer first spotted this strange shape in 2019 while reviewing sky survey data, there was only one thing she could write next to it: 3 simple letters of confusion. It made no sense. The structure appeared as a perfect circle of faint emission, like the outline of a cosmic smoke ring floating silently in intergalactic space. No visible stars. No obvious nearby galaxy interaction. Just a glowing halo, suspended in nothingness. It was labeled an odd radio circle, or ORC. At first, it was believed to be a one-off anomaly, but then another appeared, and then another. Soon enough, 5 of these mysterious circles had been confirmed, each one reaching nearly 1 million to 2 million light-years across. For comparison, the Milky Way is about 100,000 light-years wide, which means each ORC could fit 10 galaxies inside its diameter. Yet, despite their shocking scale, these structures were invisible to human eyes and even to standard telescopes. They could only be seen when astronomers scanned the sky in radio wavelengths, tuned to detect signals emitted by electrons moving at almost the speed of light. This raised a troubling question. What kind of cosmic force could accelerate particles across such an enormous sphere? And why did these circles appear so isolated, with no apparent connection to surrounding galaxies? If they were remnants of supernova explosions, they would be far smaller. If they were gas clouds, they would be visible in other wavelengths. None of the explanations astronomers relied on seemed to apply. It was like stumbling across a footprint in the desert with no sign of the creature that made it. The discovery of these mysterious circular structures, later named odd radio circles, or ORCs, began with one of the most advanced radio surveys ever attempted. Conducted using the Australian Square Kilometre Array Pathfinder, (SCAP), the project marked a turning point in radio astronomy. Unlike traditional telescopes that could only observe small portions of the sky at a time, a SCAP was built with a phased array feed system, giving it an exceptionally wide field of view. This allowed astronomers to capture enormous swathes of the cosmos in a single observation, collecting data on millions of radio-emitting objects scattered across the universe. The purpose of the survey was straightforward: catalog radio sources, things like galaxies emitting jets from supermassive black holes, pulsars, or the aftermath of supernova explosions. These were all well-understood phenomena, and astronomers fully expected the survey to reveal more of the same, just in greater numbers. The project was designed to count, not surprise. But the universe had other plans. While scanning the sky, astronomers noticed something that didn't fit into any known category: vast, near-perfect rings of radio emission suspended in otherwise empty regions of space. These circles weren't associated with visible stars, galaxies, or clouds of gas. They didn't match the structure of supernova remnants, nor did they resemble galactic jets, which usually appear elongated rather than circular. They were just rings, smooth, symmetrical, and seemingly isolated from any obvious source. Once the first ORC was confirmed as real, researchers began searching for more. The second and third were found close to each other, almost touching, but strangely different in brightness, suggesting that whatever created them might vary in intensity. The fourth was given the nickname Cloverleaf due to its uneven, flower-like shape, while the fifth contained not only a central galaxy, but also a nearby companion galaxy at the same distance. That raised suspicion that galactic collisions might play a role. But again, no conclusion could be reached without further evidence. Multiple hypotheses were proposed. One idea suggested that 2 supermassive black holes may have collided in the heart of a galaxy, sending a shockwave across intergalactic space. Such a colossal merger could release unimaginable energy, inflating a shell of accelerated particles over millions of years. But this would require an event of extreme rarity, making it unlikely to explain all observed ORCs, unless such collisions were more common than previously believed. Another possibility was that these circles were simply radio jets from active galaxies, but viewed directly along the jet axis. In this case, what appears circular from Earth would actually be elongated structures aligned toward us. While this could work for certain ORCs, not all displayed features consistent with jet symmetry. Researchers needed to determine whether their central galaxies contained active supermassive black holes capable of generating such jets. The third explanation involved something more gradual, but still powerful, a starburst event. In this scenario, a galaxy experiences a sudden surge of star formation, creating millions of massive stars that quickly explode as supernovae. The combined outflow of gas and radiation could push surrounding matter outward in a vast spherical shell. Over time, this expanding bubble would continue radiating energy, possibly explaining the uniform rings seen in ORCs. However, observations of some ORCs did not always match the expected distribution of matter from such events. Most recently, another theory gained attention after the Cloverleaf ORC was studied in more detail. Advanced telescopes detected not only radio emissions but also X-ray signatures and glowing oxygen gas across its structure. This suggested strong shock waves compressing intergalactic gas, likely produced by violent interactions between galaxy groups. In other words, two clusters of galaxies may have collided, releasing energy across hundreds of thousands of light-years. Yet even here, one major question remained unanswered. If galactic mergers are so common across the universe, why have we only seen a small handful of ORCs? It may be that these objects are more frequent than current data suggests, but we simply lack the tools to find them. Radio astronomy is still limited in coverage compared to optical surveys. Most telescopes can only search small regions at a time. Even when ORCs appear in collected data, their faintness and diffuse shape make them easy to overlook unless someone is specifically looking for them. Unlike bright galaxies or supernovae, these structures whisper rather than shout. To solve this mystery, astronomers are now calling for deeper radio observations and improved cross-analysis with X-ray and optical surveys. Artificial intelligence is also being trained to detect unusually circular patterns in radio maps. Citizen scientists have been invited to assist in classification efforts, marking down any faint rings they notice in data archives. The hope is that by expanding the search beyond a few survey fields, hundreds more ORCs may soon be found, allowing patterns to emerge. Until then, these colossal circles remain frustratingly elusive. Each one tells a different story, hinting at events so powerful that their echoes travel across millions of light-years. They may be the graves of ancient galactic collisions, the scars of black hole wars, or the breath of galaxies after a burst of creation. For now, they are silent witnesses to forces humanity has only begun to understand. These enormous odd radio circles drifting quietly in deep space remain one of the most baffling discoveries in modern astronomy. They are millions of light-years wide, larger than entire galaxies, yet almost invisible except in radio wavelengths. Their origins are still uncertain. They might be the echoes of black hole mergers, the aftermath of galactic collisions, or the fading shockwaves of ancient starburst events. What makes them truly remarkable is that they shouldn't exist based on what scientists currently understand about the universe, yet they do. Each new discovery challenges established theories and reminds us how much of the cosmos is still unexplored. Should humanity be worried? Probably not. ORCs are far too distant to pose any threat. But should humanity be fascinated? Absolutely. Because every time the universe produces something that defies explanation, it is issuing a challenge. It is asking whether curiosity can keep up with mystery. And judging by the strange circles glowing in the darkness, that mystery is only just beginning to unfold. If you enjoyed this deep dive into one of space's strangest mysteries, don't forget to like, subscribe, and share for more fascinating discoveries.